Hi everyone, welcome back to my channel, Numerics with Nadia. In today's lesson, we're going to continue to build on what we learned in our first prime factorization video. We're going to do some more practice, and we're also going to learn about something else as well. So to start off, I'll write out our lesson objectives for the day. First off, we're going to go over the difference between prime and composite numbers. We defined prime numbers in the last video, so if you haven't watched that one yet, I would recommend going back to that one because we defined prime numbers and did some basic examples. Today, we'll go through the difference between prime numbers and composite numbers, as well as doing more practice with the factor trees that we started doing last time. So to start off, we're going to start with our first lesson objective, and we're going to go over the difference between prime and composite numbers. The way we're going to do that is we're going to first define each of them and then compare them as well with some examples. So to start off, as a review from our last video, the definition of a prime number is a positive integer with only two factors, right? So it's only one in itself. And if you want more practice on that, like I said earlier, go ahead and watch that last video, but we'll also get into it briefly in this one as well. So now that we've defined what a prime number is, let's go ahead and define what a composite number is. So a composite number is a number that is not prime. So what is the difference here? It's the factors that make up that positive integer. In a prime number, it's only one in itself, but for a composite number, it's a positive integer with factors other than one in itself. So now that we've gone through and defined both of these terms and gone over the difference between what a prime number is and what a composite number is, let's go through and do some examples just so we can visually see what's going on here. So a number like 3, that only splits up into 3 times 1, right? So that would be considered a prime number. Same with 5, that splits up into 5 times 1. For 7 as well, that splits up into 7 times 1. And same thing goes for 11. For all of these, the factors are 1 and the number itself, right? So all of those would be considered prime. Now we'll move into some examples of composite number. 4 splits up into 2 and 2. 10 splits up into 5 and 2. And neither of these are factors like prime numbers, right? 1 and the number itself. So these would all be considered composite. Another example would be something like 6. 6 splits up into 2 times 3. And last off, we could have something like 14, right? 14 breaks up into 7 and 2. So those 4 would be examples of composite numbers. So now that we've gone through and just visually differentiated as well the difference between prime and composite numbers, now we'll get into some practice. The directions for problems will look something like this. So for the example problems that we're going to do, the directions are going to say, for the numbers below, use a factor tree to determine the prime factorization. Next, determine whether the number is prime or composite. So it's important to read the directions carefully, right? In this type of directions, we have 2 questions we have to answer. First off, we're going to do prime factorization, same steps as we did in our last video using a factor tree. And then we also have to answer the question and determine whether the number that we did the prime factorization for is prime or composite. All right, so now that we've read through the directions, let's get into our first practice problem for today. For our first problem, we have the number 67. And if we think of 67, it's not divisible by 2 or 3 or 4 or 5, right? So the only factors of 67 are 67 and 1, right? And that is 1 in itself. So 67 would be considered a prime number since it only has factors of 1 in itself. Now we will move on to our second practice problem for today. We have 48, and we know 48 breaks up into 6 times 8, right? So we can continue with our factor tree. 6 breaks up into 3 and 2. for the left-hand side, and then 8 breaks up into 4 times 2. And then the 4 will break up into 2 times 2. So for this one, all of the factors that we're left with are prime, right? The 3, 2, 2, 2, and 2. Since we have a lot of factors going on, I'll rewrite it for us. All of that would be equivalent to 2 to the 4th times 3. And clearly, 48 has factors other than 48 and 1, right? So we would classify number 2 as a composite number. Now we'll move on to our third practice problem of the day. For number 3, the number that we have is 35, and we know that 35 splits up into 7 times 5, right? 7 and 5 are factors other than 35 and 1, so we would classify 35 as a composite number. We have a few more practice problems for today. The next one will be number 4. For number 4, we have 88. And when we think of the factors of 88, we know that 88 splits up into 22 times 4. The 4 will split up into 2 times 2. The 22 will split up into 2 times 11. So the way that we'll rewrite this, since there's a lot of factors, which are all prime, right? We have 2 times 11 times 2 times 2. That would be equivalent to 2 cubed times 11. And clearly we have factors other than just 88 times 1, right? So number 4 would be composite. All right, you guys, for number 5, we have 71. And for 71, it's not divisible by 2, 3, 4, 5, right? It doesn't have any factors other than 71 times 1. So that would be 1 in itself. So we would consider 71 to be a prime number. All right, you guys, last practice problem of the day. We have 52, and 52 will split up into 26 times 2. The 26 we can break up into 13 times 2. And all of these numbers left are all prime numbers. Since it's more than 2 factors, I will rewrite it for us. That would be the same as 2 squared times 13. And since our factors are different than just 52 times 1, we would consider 52 to be a composite number. All right, you guys, great job making it through all those practice problems. Thank you guys so much for watching. I hope you enjoyed the lesson today. Feel free to like this video if you enjoyed it, subscribe to my channel if you haven't already for more math-related videos, and comment down below if there's any other topics that you would like me to do a video on, and I will see you guys next time.